So first of all, I would like to thank you for being still here on the room. I know it's a bit late. I know that you already watched a lot of speeches and you must be probably a bit tired, but I would like to thank you. And I would also like to say a special thank you for Anvar. I met Anvar last year in May in Estonia, and on the night we met, Anvar told me about this global symposium. And there was a person nearby us, and that person said, engineering symposium in Azerbaijan is going to be a room full of men. So I would like to ask all Azerbaijani women that are studying engineers or are engineers to stand up, please. I don't know if someone can translate me if they don't understand. So I see around 19 and 20 girls. So I guess there is 19 and 20 reasons that that girl was wrong. So thank you very much. Give a round of applause, please. Okay. And I will also like to invite you to try and check these pieces that were made by 3D printer machines. The alcohol here for the hand. So if you like, you can share it with other persons. Thank you. So about my presentation. First, I will talk about my personal path towards the field of mechanical engineering. Then I will also talk about the importance of the field. Secondly, I will pass to my main theme, which is 3D printing. The concept behind the idea, the theory that this is a new plasticine in teaching, the designs and innovation within the industry. I will focus more on the automobile industry and the advantages in the market regarding other industries. So when I was young, I got some toys from my father and my mother. And I was very clumsy, so I was all the time breaking the toys. But at the same time, I wanted to fix them. I wanted to understand how they work from inside. So then I passed to the bicycles. I watched the strings, I watched the wheels, I watched all the metal that is inside. So when I was in the 12th grade and I was trying to decide what to follow, I asked my uncle, which is electronic engineer, and I asked my father, which is a mechanical engineer. And later I decided to go to mechanical engineer because I want to know how the things work. I want to know what is behind the curtains when you see all of these objects, even the simple chair. How does the chair recline? And I went to ISEP. ISEP has a lot of programs for foreign students. So if you would like to ask me questions later about ISEP, you are most welcome to. Nowadays in Portugal, for example, to point out the importance of mechanical engineering, all the grades to enter university are getting higher. In the past, it was medicine. Now, the best students from secondary schools are engineers. Our grades are from 0 to 20. So as close as 20, the better the grade is. Here's some data I got. I'm sorry that is from 2014, but it was the best I could get. But you see that they are posting more jobs about engineers than there are people to hire. So all of this square is for people that they have the job, but they don't have the person to work with. So, and also the importance of mechanical engineers. Some 3 million people are employed in the sector in the European Union. It's responsible for 9.5% of all the production of EU manufacturing industries. Europe is the world's largest producer and exporter of machinery with an estimated 36% share of the world market. So it's a sector that is ready to explode in the future. So we need to catch up with the train and form even more students so it can create new job opportunities and hopefully more startups for mechanical engineers. And what are the thoughts about the companies that they want to hire mechanical engineers? They are relatively high manufacturing intensity, so a lot of products coming from the assembly line. high qualification requirements for staff and manufacturing departments. So it's a person who has to deal with a series of staff, from the simple worker to the boss, to create a connection between all of them with the products and with the requirements and measures. So there's relatively complex communication requirements between manufacturing, engineering, and design departments. But what are the future challenges? The research is vital to the competitiveness of the sector. So nowadays, most companies are putting like very strong ideas on creating patents. Because nowadays, what you create and you don't do a patent, someone, for example, in China can do it for much lesser price because of the huge market they have there of prime materials and stuff to work. So it's always important to protect your ideas. So you have to create patents. And there is also a need for a stable, predictable, and coherent regulatory environment that embraces smart principles and is straightforward as possible. It means you have to create clearly and directive ideas. So the job is done by the simplest worker as fast and as simple as possible. For example, it is my personal path to show how huge is the mechanical engineering field. First, I was working in this company, Arvorense, which is the company that makes these boxes with hydraulics here. And now I'm working in Smartex, a startup based on creating prototypes to detect fails on the looming machines, on the tissue that they produce. So, like resuming this all, a mechanical engineer needs to be someone with capability of multitasking, problem solving, requires a lot of coffee and probably Herdolan beer. So you need to have all of these four goals. So about 3D printing. Is the process of making three-dimensional solid objects from a digital file. It's the opposite of subtractive manufacturing, which is cutting out, hollowing out a piece of metal or plastic with, for instance, a milling machine. So instead of creating a steel plate, then bending, then making drills, which is subtractive manufacturing, the 3D printing is about addition of material to create the shape that we want. Also enables you to produce complex shapes using less material than traditional manufacturing methods. So this is like the basic modus operandi. So it all starts with a 3D model. It can be, for example, SolidWorks or Autodesk Inventor. And then you can create one yourself or download from a 3D repository. When created yourself, you can choose to use a 3D scanner, app, device, code, or 3D modeling software. And then comes to the slicing part, dividing 3D model into hundreds of thousands of horizontal layers using a proper program. But already some of the programs in the 3D printer machines, they already have this tool. So you don't need to actually create the file. So dividing by steps, this is the CAD file development. So you have to use a computer-aided design program. For example, in this picture, this SolidWorks. Then you can choose the material, the colors. Then you pass that file, that 3D file, into an STL type of file. So some programs already have this option when you save the drawing. What the 3D printers machines usually are from is using the stereographic technique, most commonly referred as SLER, is one of the most popular and widespread techniques in the world of additive manufacturing. It works by using a high-powered laser to harden the liquid resin that is contained in a reservoir to create the desired 3D shape. So we have here the computer saving the file from CAD to STL. Then there is the layers. Here's the laser slicing here in the resin, and then it creates this shape. Of course, there are other types of techniques. For example, we have deposition modeling, FDM, and selective laser sintering. We can also divide SLA for DLP, digital light processing, and LSD, liquid crystal display. In the case of DLP, a projector casts light over the entire layer to cure it all from once. From LSD, the LSD screen either masks a projector's light or uses its own light to cure the entire layer at once. So, in case of those other tools, the FDM and the SLES, an FDM filament is fed through a hot extrude and positioned layer by layer. These materials are typically thermoplastics, but it can also be mixed with other elements, including wood, metal, and carbon fiber. This is one of the major advantages over SLA, which has a limited choice of materials. For example, ceramics, mostly resins. The cost of materials is decisively lower for FDM, since the printers are more affordable and plastic reels are cheaper than resin. If high precision and a smooth finish are priorities, SLA will be the best choice. If cost and to a lesser extent our durability plays a role, an FDM printer is the best. In case of SLES, selective laser sintering, this guys is a new powder, and this laser will use this new power, will sinter. So, and of course it is more powerful because instead of curing a substance, the beam hits a powder to the point of fusing with particles together. Prints are especially strong and durable, also because supports aren't necessary. Prints can be of complex geometries. So if high mechanical strength and complex shapes are your priority, and the cost is of minor importance, use a SLES. Otherwise, SLA is still the best choice for you. But I was talking here of so many of them, and my focus should be SLA. But why SLA is better? Is one of the most precise techniques on the market. The print surfaces are smooth. Compare like this picture with this one. See the endings. And of course, the sizes are not the greatest. You know, we are talking about 50 by 50 by 60 cubic centimeters without sacrificing precision. So it's rather small objects. But of course, there is also something against SLA. So prints tend to take a long time. For example, for a 3D printer machine, the fastest you can get is around 10 minutes. But for big objects with complex shape, it can take several days. So it's all about the waiting there. Steep slopes and overhangs require support structures during the building process. Also, a good technician to operate this 3D machine. We're also talking about that. Resins are comparatively fragile and therefore not suitable for functional prototypes or mechanical testing. Offers limited materials in color choice, mostly ceramics and resins, usually black, white, gray, and clear material. So the choices of color that the printer machine produces with SLEI is not the greatest extent. And those resins are oftentimes proprietary and therefore cannot be easily exchanged between printers from different brands. So the resin from the printer number X and the resin from the printer Y, they are very different. So you cannot change between one of them. So there's only a small choice in the market. So passing now to the third stage, there is now the Stl file manipulation. So after you create the Stl file, you need to choose all of these categories from the height, from the velocity of the machine, from the materials. So when the file is ready with you, all the computer needs is a 3D printer which can print using the stereographic technique, SLEA. But before this, users will have to set the orientation and size of the object to be printed. This is similar to the case of the 2D printer. So we also choose in a 2D printer to choose how the text will be on those paper, if it's horizontal, if it's vertical, and everything. Then the fourth stage, you need to prepare the printer. Of course, it needs to be connected to the energy, but we also need to make sure that we install the polymers, we install the materials that we need, which is necessary to perform the print operation. Once such requirements are met, you're almost ready to print. Then there is the building up. Now with this part is all about waiting. You know, as I said before, it can take up from 10 minutes to several days, depending on the size and the complexity of the material. Then it's the post-processing stuff. You can just not take it, the piece, and try to push it hard with your hand. You know, you need to be careful using the first time the material. So, and talking about the materials that can be used, there's all this variety of choices, even chocolate you can use with chocolate in the 3D printer machine. So there is all of these metals here. There's gold, silver, titanium, stainless steel, aluminum, cobalt, copper, bronze, iron, platinum. So, but where nowadays these 3D printed materials are used on what? What in our society? Dental products, as we saw before with that skull, with like a substitute for the bone on this side. There's also for eyewear, architectural scale, models and markets. There's already some cases that in the future you will be able to make your own house with a 3D printer machine. So basically what you need is to buy the land and print a house for yourself, movie props, design furniture, reconstruction fossils in paleontology to study them, replicating ancient artifacts in archaeology. If some of them are a bit destroyed, it's possible to create a piece to fill that gap and rebuild more or less that object. Reconstructing bones and body parts in forensic pathology. Reconstruction heavily damaged evidence retrieved from a crime scene. So it can also be used for the police. So right now I will talk about this new theory that 3D printer machines can be the new plasticine in teaching. I don't know about you, but when I was a child, I did a lot of constructions in plasticine. In our school, we used to do that to explain our ideas and to show how good or how bad we were. So in 3D printing has brought greater spontaneity and ease breathing life into new projects, using a machine at the highest level of craftsmanship, since each piece is individually produced. In this way, someone being trained can not only adjust their own projects in an easy and accessible way, but can also create variants of their pieces, whether it's color, shape, or details. So, what we need to implement this new idea around the schools is to create more easy and simple access in these programs of creating 3D pieces like SolidWorks. So, if there is like an investment for creating types of these programs for school for young children, so it's possible to create more engineers, more architects that we learn since from a young age to developing these pieces and put them to test. So comparing the past and the future of 3D printing as the new plasticine in teaching. It brings to life the trainees' work and gives them means to see that they make shapes that genuinely motivate them. So something that you can create in a computer in a couple of minutes, the piece is already in front of you. So it can be, in the past, people must think like it's like magic, but nowadays it's possible to do this. The demand for technology in training classes has opened the way to ever more open technology to see educational needs. Just as children in the past like plasticine because it helped them to mold their ideas in an easy, practical way, 3D printed technology is the new plasticine of modern times, making interactions with project as fast as imagination and the printer allows. As I said before, around 10 minutes. But is it changed for better? We notice how trainees begin to present high levels of motivation and concentration. So there are already studies that proves that using these 3D printer machines, the children get more motivated and more concentrated. So, and they have the opportunity to show to their teachers and their colleagues their imagination into a new whole level. So this is always here some examples that you can use here in the classroom. So there is also for biology, also chemistry students, more mechanical engineers. So, and within the industry, it began as a tool for a quick prototyping and validation testing for different stages and design of engineering process. allow the discussion and sharing of knowledge, especially function and assembly requirements between project teams and suppliers. For example, nowadays Formula One uses extensively the gearbox made by a 3D printer. So and how mechanical engineers can enter in that equation, it can be more flexible when they're developing and testing solutions. So they have more freedom to test their ideas, not work with the whole team to make a prototype that can last for months to make, and then it needs changes again. So we are talking about a process of years. So with 3D printer, they can reduce that process to a couple of days. Also, speaking a little about the mold industry, very complex cooling channels can be created by a 3D printer, reducing the cycle time of injection molding. Repairing a crack in a product of high value can be a lot cheaper and quicker than having to mold a replacement. That's why it enters in the artifacts. If is the idea of rebuilding an artifact to this original shape, you can use a 3D printer. Because of replacement of a nation artifact is impossible to get. Also, it's important about the elimination of collection elements. Here you have 6 collection elements. You have 1, 2, and 4 screws. Now with 3D printer, you can reduce this to 0 elements. So this is basically 1 piece, not 6 pieces. This has enormous potential in optimizing components optimization, allowing a reduction in its geometry and the amount of material needed for each one. So this piece is for sure much more lighter and more eco-friendly than this one. This factor alone has a great impact on the environment and the economy. But of course, there is also challenges in the industry. You know, is not just put like a 3D printer machine in the middle of the factory and expect to magically work. You know, you need to hire technicians. You need to give them hours and hours of training. So there's a lot to work with, and you know, you need to decide which is the type of material that you are going to use. So they don't have the same properties of the objects that have been conventionally manufactured, since the microstructure is different. But in the future, as 3D printing becomes more homogeneous, costs are expected to fall, especially the cost of materials. So, in the future, it will be more easy to require more talented youngsters. 3D printing provides additional technology that can exercise their creativity to an advantage. So now I'm going to show you more or less the advantages in the market. So this is more the typical from the company. There is an idea. There is a 3D modeling, for example, in SolidWorks. There is a validation prototype. There is a manufacture of final items, the assembly, the distribution, the storage, sales channel, buyer during the process, transport of goods from one place to another. So it's a huge quagmire. So, but with 3D printing, of course, this is a very simple way of saying, it's not correct in all of the cases, but the main idea is to have just the idea of the client, the design in 3D modeling, and the prototyping by the end user, the buyer. So you guys come to me with an idea, I do in my home, in my SolidWorks program, I send you the idea, you have in your company a 3D printer machine, you just have to print it, and that's done. Over here in this picture, there's also military applications. There was a case in a couple of years ago in the United States that someone created in SolidWorks a gun, and actually that gun made by a 3D printer machine can be deadly. So the American government tried to erase all of these designs of the guns, so people just cannot make guns at home when they want. So thank you all for your attention, and
thank you very much. Do you have a question? Okay, we can take just one more question so we can wrap up.
Firstly, I want to thank you for this presentation. And
Thank you for being here this time.
Yes, thank you. And I want to give you some question about the software part of this 3D modeling. And you have talked about SolidWorks and Inventor as a programs.
Yeah.
And I know that I can make some objects as a 3D modeling in AutoCAD, and what's the main difference between objects created on SolidWorks and objects created on AutoCAD? And another question is that about 3D print, and you say that this is obviously use electricity, and
Yeah.
if the electricity shut down, what will happen? It will start where it stops or not? And the another question that you said that we can create our homes with the 3D modeling. It's true. And I think that there are two houses. One of them is from stone or wood, and another one is about created on 3D modeling. What's the strengths? I mean, windy. It will be whether windy or rainy. About strengths about two objects. That's it.
So regarding the question of the program, I think SolidWorks is much more useful when you're dealing with the 3D designs. AutoCAD, for me, it's more useful for 2D designs. About the electricity in the printers, some of them already have small batteries inside which can store up energy. So when the power goes down, this storage battery can have a durability of hours. It's, for example, like our solar panels at home. If you have a solar panel at home, it's impossible that you're going to have 365 days a year of sun. There's going to be days of clouds that occupy all the sun. So there is ways to store as energy. And about the homes,
Yes.
I think first you need to study the area that you are going to build on this home. You need to study the weather conditions. You need to talk to professionals to ask which is the best material that you can use. And comparing to rocks, I think is more eco-friendly. Because rocks, you need to go to a nearby mountain and sort of cut the place down, to retrieve all the rocks. But I think 3D printer machines are much more eco-friendly than we think of.
And depend also weather situation, weather.
The weather situation.
Okay, thank you.
For the question. Thank you for joining us.